I'm recording this. Don't walk in late and ask questions, please. Just walk in late, sit down, and start taking notes. So let's go over this. I'm recording this so you have a copy of it. You're getting your old quiz back. You're going to have another quiz on Friday. So newly identified fruit fly mutant, right? It says Cyclops eyes, large and single in the middle of the head, is hypothesized. See, there's that word hypothesized. So what do you think that means? So this is the hypothesis that the scientists have. That's right, scientific guess. The experimenter started with homozygous wild-type females, and this is what confused about half the class. I could name the people that got confused. I can't have anyone talking, and everybody should be in dress code. The experimenter started with wild-type females, and so if they knew automatically that it's autosomal dominant, that Cyclops is autosomal dominant, is big C blank, then they know that wild type, which is the opposite of Cyclops, is little c. They knew that from the first sentence. From the first sentence, you knew that. If you have a hard time seeing that from the first sentence, then, gosh, you got to see me after school. I don't know what else to say. So that much we know. The experiment started with homozygous wild-type females. So it started with females that were homozygous wild-type, and then it started with males that were homozygous Cyclops. And then this is the trick. This is the thing that got most of you. Well, not most of you, but half of you. The other half got caught a little later on in the problem. You see F2 generation, and you forgot what F2 means. So it says that they crossed these two, male and female, and they ended up with what percent heterozygous? What percent heterozygous? 100% heterozygous. And I want to say about half of you, what you did is you went off these numbers. That was wrong. You don't go off these numbers because if you read on in the paragraph, it says, I can hear people talking and kind of messing around. I hope you can straighten up before the end of this because we don't have time and I'm not going to discuss it because we got places to go. So it says the data from the F2 generation. So the F2 generation means you take two of these and you cross them. So you're taking a wild type, cross them with a wild type. We've gone over this. You should know what this means. When you see F2 generation, if you don't, you got things a lot of catching up to do. So what you have this cross. This is the cross you're going to analyze because that's what you have results for. What you have results for are 4 different phenotypes.
Wait.
4 different phenotypes. You have 4 different phenotypes here. What are those 4 phenotypes in the problem? They say 44 wild type males. They say 60 wild type females. They say 110 Cyclops.
That's the observed one.
This is the observed, is correct. Males. And they have 150 Cyclops females. Now, you got to understand, when you're looking at this, that these numbers, these are your observed. For this cross, this is what happened. They did this and got these results. So if you're going to come up with some predicted that you're going to compare to these, if you're going to come up with some predicted values to come up and compare to these observed, are you going to use this, number 1, or cross number 2? Number 2, you have to use in order to compare your data, you have to predict what the results from the same experiment that you got results from. All right, so right there, you should have enough. You have enough right here to do the chi-square, no problem. Let's go ahead and do it. It's really pretty quick. The kids that you see results for, they did that work in like, they got a little longer, like 25 minutes, not 20. But they did that work a little longer than you had. They begged me for a little more time, and they got 25 minutes instead of 20. But they did it well. All right, so moving forward, what are predicted? We know what, if we go ahead and try to fill up the chart, we know our phenotypes. What are our phenotypes? That's right. Your phenotypes are coming from here. These are your phenotypes. You know, people that didn't know what to do, they should have at least filled in phenotypes, right? Wild type, males. It was a chart. You could have easily filled that in. Wild type, females. Cyclops, males. And cyclop, female. Now, automatically when I see this, I'm thinking my brain is ticking away, and I have a question like if the phenotype is wild type and then males and females and male and female, I have to take male and female into consideration. What are going to be the chances of getting a male or female? 50%. So I know that has to be somewhere in my thinking that has to be there. All right, so then the next question is number of observed. And the number of observed are here, 44, 60, 110, 150. 100% of the people should have got this done. 100% of the people should have. Now, the expected was going to be a problem for some people. All right, the expected was going to be a problem. Not for everybody, but for some people. Actually, I want to say for a lot of people, but not for everybody. So how do we find the expected? You're going to use cross number 2. Punnett squares give you, and whether it's a dihybrid cross or a monohybrid cross, doesn't matter. Punnett squares give you your predicted values. That's what Punnett squares do. They predict what the results are going to be. All right? So that's it. That's would be expected. Expected, another word for expected, is predicted. So in the predicted values, as you should know, big C, right, should be cyclops, right? But look, here's another problem. This is where a bunch of people got caught up on this as well. Let's think about this. Are these phenotypes or genotypes? Phenotypes. So if you're gonna, the prediction has to be the prediction of what? Phenotypes. Because you don't know if these are homozygous, dominant, or heterozygous, right? So when we're looking at numbers, what you got to worry about is percentage of phenotypes. Just like in the lab, right? When we did our dihybrid crosses and we looked at phenotypes. Now, the phenotype here is, how many of these are cyclops? Are cyclops. Remember cyclops we think is autosomal dominant. 3 out of 4, that's right. 3 out of 4 or 0.75% or 75% are cyclops. How many of those are female? 50% of. So 50% of 75% are going to be female cyclops. And 50% of 75%, and that's just multiplication, are going to be male cyclops. What's 50% of 75%? It's do the math. You have to do the calculator. That's another issue a lot of people had. You got to be careful with these zeros. The zeros will kill you. Use the calculator carefully. Yeah. All right, so anytime you have a dihybrid cross, both the heterozygotes are cyclops and the homozygous dominant is a cyclops. So there's 3 out of 4. The phenotypes, not the genotypes. All right, so that's the key. That's a problem. That's what's going to lead you. Always it messes up your numbers. All right.
It's 0.375.
0.375 is what you have for males and females. So But that's not the number that goes here. What number do we want here, since we're gonna be comparing it? If we're gonna be subtracting out of them, they have to mean the same thing. This is what? This is 37.5% of what? The total. So you add these up. You know, this is another thing, one person only messed up. You look at the examples I gave you, the only thing they messed up is they added wrong. This is 364. Some people put 360, I don't know. But I think it comes out to 364. Do your math yourself, I'm not sure. So it's 37.5% of 64 is what? 0.375 times 364 is what? What is it? Say again. 45.5. And that's the same for both of these. You see that? For both Cyclops male and female, because there's the same percentage, you see? Now, that's one. That takes care of Cyclops female. I took do it on the calculator, 0.375. That's your probability of either getting male or female, and multiplying it times your total. Always you're looking for your total. That goes for Hardy-Weinberg and for chi-square. When you're talking about probabilities, it's always some percentage of what? Of your total. Always your total.
You multiply 0.375 times 364.
Yeah, and you get 45.5.
That's not what I got.
What'd you get?
It was 136 something.
364 times 0.375?
It's 136.5.
All right. Somebody told me 40. I know the other answer is 45 then. I know one's 45.5. So it's 136.5, right? 136.5. 136.5. Are we good?
Yes.
All right. So that's Cyclops. Now what about wild type? Well, wild type is going to be what percentage? 1/4 or what? 0.25, right? Our wild type, and then how many are going to be male and female? It's going to be 0.25 of 50% of 0.25. That's right. What is that? That's half of that, and that would be male. And then female is the same thing. That's why these numbers are going to be the same. That's one easy way for my grading. When I look at your grades, and when I went to grade your stuff and I saw that these weren't the same, I knew you weren't doing it right. These two should be the same, and these two should be the same, right? Because they're just half of each other, of the total. So anyways, female should be 0.125. What's 0.125 times 364?
46.
Somebody says 46.5. Somebody else told me 45. What is it?
45.5.
45.5. All right. So you got to go 45.5. Do the math. Use the calculators. And by the way, when you use my calculators, could you return them? Because a lot of people didn't return them.
Now, Miss Miller, did
Yeah.
you say something like if it's greater than observed,
Well, we're not there yet, but let's go ahead. We'll see. It's going to be the chi-square that you're going to use to compare. So then the next thing to do is decide, is to take the observed and minus the expected. So subtract the two. And can somebody tell me the numbers they got? Did anybody get it right? Look at the example that I sent you. Somebody give me the results. I don't want to do all these calculations.
negative 1.
So the first one you say is negative 1.5. That would be expected. Now some people subtracted these two, or maybe they added them. I don't know what, but they got some really weird numbers here. Look at your. Those of you that did it, look at these. Look at your quizzes. This should be this one this one minus this one. So 44 minus 45.5 should be a negative number, right?
Yes.
And it should be a small number. I've seen the number 11 here. I saw the number 20 here. I was like, I don't know what's going on. All right, so what's the next one?
It's 14.5.
14.5, that's reasonable. See what I just did? I checked it. I said, is that reasonable? I think that's reasonable. Next.
26.5.
26.5. What's the next one?
Negative 13.
Negative 13.5. What? The one above is negative what?
Negative
13. And what's the next one?
13.
Just regular 13 or negative?
Regular.
It doesn't really matter because you're gonna square them. Now, could someone square them? I just like to be accurate if I could.
So we're squaring the 45, 45, and the next.
See, look, guys, when you're given,
Squaring that.
when I give you the formulas at the top of the thing, it's giving you information. So see this area up here, it's telling you what? To take this, isn't this the same as this? And do what? Square it.
1.5,
1.5 squared is what?
2.25.
2.25. Notice it's positive, right? And you expect that. 2.25. Quick question. We're running out of time.
If you were to do it, if you were to square them first, and then subtract them, would you do the same things?
No. All right, next.
That doesn't make sense.
If you squared both of these and then subtracted them, okay. But why would you? They wouldn't work. All right. You have to subtract them first. All right, so just follow the order. Everything is told to you right here. The story is how to do what you do is right. Was all up here. All right, what's 45 minus 14.5?
Oh,
You mean 14.5 squared?
I'm sorry. You're right. What is it?
210.25.
And what's the next one?
702.25.
And the next one?
182.25.
Now we're gonna take. Well, what are we gonna do? We're gonna take these numbers and divide it by e, which is this, right? So what is it? What do we got? 2.25. 2.25 divided by 45.5.
How you want us to round?
Don't just give me the number. I'll decide.
0.049.
All right, next. See, there's whole rules of rounding, a scientific notation that are
Next
a
one.
whole set of rules of rounding that we call significant digits, and we're not going to worry about that, but that's something you need to worry about in the future.
The next
Go
one
ahead.
is 4.62.
4.62. Go ahead.
5.14.
5.14.
Last one is 1.33.
1.33. And so again, when I got numbers, when people summed them up, by the way, what's the sum of these? The sum of these is what we call chi-square. All right, that is the number. That's the number we're looking for, is the sum of these. What's the sum of these?
It's 11.179.
It's 11 point, what? 179. That's the number we need. That's chi-square. Then what we do is, this is the number we use to compare to our critical value. Our critical value, this is one person messed this one up. How many different phenotypes do we have? How many different possible?
4.
There's 4 different possible. So our degrees of freedom are equal to n minus 1, which is equal to 4 minus 1, which is equal to 3. 3 is our degree of freedom. We choose our probability to be 0.05 because that's what we do, all right, unless we're told differently. And what we find is that what our critical value is equal to 7.815. The question then becomes, oh, jeez.
Wait, so the degrees of freedom
How do
and
you-
the 0.05, what did you do with it?
Chart. Look at your chart, guys. Look at your chart.
Oh.
Degrees of freedom is on the left-hand side. It's 3. That's your row.
Oh, we on the next
And your probability is what? 0.05. So where did 0.05 and the third row meet?
Oh.
What's else? 7 point. That's just reading, guys. All that is reading the chart.
Keep going back.
I got one more extra quiz if you need it.
On the quiz, when you put that, the one that we need,
How did you find N? Like, how-
Okay, listen, she's asked a very good question. A lot of you don't realize. To find n, you ask yourself, how many different possibilities do I have? How many different ones do I have? What are my possibilities? Only these 4. My n is that possibility. Minus 1 is 3.
Why you minus 1?
That's just the formula. Yeah. Go and get some. Write it. Here's your universal pass, dude. Whatever, man. Come here and get it. Be quiet. Get that out of your ear. I'm moving on, guys. We're running out of time. So now your question is, shh. Your question is my chi-square greater than or equal to my critical value?
It's greater than.
My chi-square is 11.179 and it's 7.815. So what do? I reject the hypothesis. I do not think that this is autosomal dominant. It is not that, it's something else. And that's your answer, and you're done. You're moving on to the next problem. Now, moving on to the next problem. I will post this, but of course people don't want to do that, so I'm not going to get into that battle. All right, so as I said, make sure you these are the correct equations. There was an error on the quiz. I told you to correct it. It's p squared plus 2pq plus q squared. This was actually the easier one. It took people like minutes to do. If you know what these variables mean, this is easy. All right.
Well,
People who don't, then you got problems. So it tells you automatically. It tells you something. It said homozygous recessives are 4 in 10,000. Well, homozygous recessive, what is 4 in 10,000? It's 0.0004, and that's your probability of having a homozygous recessive. Which one of these variables represents homozygous recessive? It is not Q. This is frequency of the small, I'm going to use C again, small c allele. Small c allele. This is allelic, these are what we call allelic frequencies.
I thought you just said that one was wrong.
This is not, I did. Homozygous recessive, is that one little c or is that two little c's? Two little c's. So this is only for one little c. Where do you see one that has two little c's?
Q squared.
Q squared is little c, little c. What is p squared?
Big C.
Big C, big C. What's 2pq? Or what's pq? Big C, little c. And what's p? Big C. So this is the frequency of just big C in the population. This is the frequency of little c in the population. This is the big C, this is big C, little c, this is little c, little c. All right, so what did you find? What did this give you? What did it give you? P, Q, P, 2P, P squared, Q squared, or 2PQ? Q squared. Repeatedly, the mistake that people make, this should be an announcement, this should be a warning for you. This should be something you don't do because I'm telling you don't do this. If you see recessives, that tells you Q squared. That tells you Q squared. So Q squared is equal to that. So if Q squared is equal to 0.0004, that's one of our, because the question asks you, what are the expected frequencies of the three genotypes? Big C, which is equal to P squared, 2PQ, which is big C, little c, and finally little c, I'm sorry. Somebody close that door. Q squared, which is little c. So that's what they want. They want to know what are your probabilities for each of these. Q squared you already know is 0.0004. That's easy. Or you could also write it as 0.04% if you want. Either way. How are you going to find P squared? You have to use this formula. Look at it. Look at it carefully. Another big problem people had on these quizzes is you don't know the difference between square and square root. You got these two. Can I take this number and put it into here? No, I can't. That's why I'm telling you, most of the people that got it wrong on the quiz, what they did is they took this number, subtracted this from 1, got 0.999, and they used that for Q. That does not work. Right, it's not divided by 2, but it's a good try. That's what a lot. That's yet one more thing people do, because you don't understand what square, the opposite of square is not divide, it's square root. So you do this, you take the square root, which is this thing, and that's on the calculator. If you don't, it's just a square root symbol.
It's called a radical.
It's not, just a square root symbol, please. So with these two, the square root cancels the square, and you get q, and that equals what? It equals 0.02. So q is 0.02. You use that to get your p. P plus q equals 1. That's 0.02 equals 1. So p equals 0.8. No, it doesn't. No, it's 9.8. Again, you can just do the math on a calculator if you don't know that, but it's 0.98 is your P. So now you know your P and your Q. Now, some people took this number and put it into here. That can't be. This is P. This is what? P squared. So you got to square it. You got to square it. If you square 0.98, what you get is 0.96. So when I saw people put 0.98 here, I knew they were wrong. This is 0.96. Now, how do I find 2PQ? That's easy. I use this number and this number, and I say 2 times 0.98 times 0.02. See how easy this is? Somebody do the math. Yeah, I know, and you got it right, I think. What's the number? I remember grading yours. Yeah, you got almost.
1.5.
What is it?
1.5.
You multiplied these three together. Yeah. Can I get a verification on that with people with calculators? I believe you. I just want
0.039.
0.039.
Are y'all factoring out 2 or no? No. Okay, so then it's 0.02.
Now, how do I know that this is more reasonable? Look, listen carefully. What do all three of these have to equal? 1. They all have to equal 1. So when I look at this plus this plus this, it's reasonable that equals 1. Right? 96. If I add 9 and one of these is 10, right? And so then I got 3 left. Anyways, it comes to about 1, right? All right. Yeah? No, you don't square the Q here. You don't square the Q or the P. This is not squared. Hey, don't confuse these. A lot of you are going to leave here thinking, I know what's going on. Not going to know for sure until you're practicing it. This and this is not squared. That's another mistake people did. You're not using P squared or Q squared. Look at the formula. Using P and Q. So look at the formula. P, 2 what? 2 times P times Q. Not P squared, not Q squared, right? 2 times PQ. So it's 2 times P times Q, which is this, which is 0.039. Are we good?
Yes.
All right, pack up. It's time to go.
Can you leave this stuff here?
No, there's another class in here. We won't be back.
Did you record that stuff or not?
I recorded it, and I'll be sending it out. What? Is this says, what does this say? Does this say 0.39, 0.039? What does this say? It says 3.94.
I don't know how it's that.
I know, I'm just saying it's almost. I think you came very close. You're one of the top kids. Do you know how many people turned in a blank sheet to me?
What?
You should be very proud.